Digital currency is money that exists only in electronic form. There are no notes and no coins. And the first thing to say is that most money is already like that. The balance in a bank account is a number in a database. The physical cash in circulation is a small fraction of the money that exists. So digital currency by itself is not the new idea. What makes cryptocurrency different is not that it is digital, but that it has no central authority behind it. An ordinary bank balance is a number in one organization's database, and that organization decides what it says. If the bank's record says you have £100, you have £100. Cryptocurrency removes that organization, which creates an immediate problem. If nobody is keeping the official record, how does anyone agree on who owns what? That problem is what blockchain was invented to solve, and the whole of this lesson follows from it. A blockchain is a digital ledger, a record of transactions that is decentralized, meaning copies are held across many computers rather than in one place, and that is designed so entries cannot be altered once written. Transactions are grouped into blocks, and the blocks are joined into a chain in order. The shared diary analogy on the page is a good starting point. Imagine a record book that everybody in a group holds an identical copy of. When a new entry is made, everyone's copy updates. Nobody owns the master because there is no master. And if one person alters their own copy, everybody else's copy disagrees with it, so the alteration is simply rejected by the majority. That is decentralization doing the work a bank would otherwise do. Instead of trusting one organization to keep an honest record, you rely on many independent copies agreeing. But the copies alone are not the clever part. The clever part is how the blocks are joined. So let me show you. Each block contains three things: the transaction data, a hash of its own contents, and, crucially, the hash of the previous block. A hash is a value calculated from data, where changing the data even slightly produces a completely different hash. So each block carries a fingerprint of the one before it. Now watch what happens if somebody tries to cheat. Here is a chain of 4 blocks, each holding the previous block's hash, and everything is consistent. Suppose an attacker alters a transaction in block 2, changing an amount in their own favor. Block 2's contents have changed, so block 2's own hash changes. But block 3 still stores the old hash of block 2, which no longer matches. Block 3's link is broken, and the tampering is immediately detectable, so the attacker would have to recalculate block 3's hash too, but recalculating block 3 changes block 3's hash, which breaks block 4, and so on, all the way to the end of the chain. To alter one historical transaction, you must recompute every block that follows it, and do it faster than the rest of the network is adding new blocks on a majority of the copies simultaneously. That is what people mean when they say a blockchain is immutable. It is not that alteration is forbidden. It is that altering one thing requires redoing everything after it. So how does a payment actually work? Someone requests a transaction. It is broadcast to the network of computers, the nodes, rather than to a bank. The network validates it, checking that the sender genuinely holds what they are spending, using the ledger's existing history. Verified transactions are grouped into a new block. That block is given its hash and the hash of the previous block, and is added to the chain. And every copy of the ledger across the network updates. Notice what is absent from that sequence. At no point does an institution approve anything. The validation is performed by the network collectively against a record that everyone holds. That is the whole design goal. Replacing an institution you must trust with a mechanism you can verify. The advantages follow. Transactions are secure and extremely difficult to alter, for the reason we just watched. There is no central authority, so no single organization controls the currency or can freeze an account. Transactions are transparent, since the ledger is public and anyone can inspect it. And cross-border payments can be faster and cheaper than through banks, because there is no intermediary taking a fee and a few days. The limitations are just as real, and a good answer gives them. Cryptocurrency values are highly volatile, changing dramatically in short periods, which makes them poor for everyday pricing. It is not widely accepted as payment. Mining, the computational work of adding blocks, consumes very large amounts of electricity, which is a genuine environmental cost. The anonymity that protects legitimate privacy also attracts criminal use. And there is no recovery. If you lose the key to your wallet or send funds to the wrong address, there is no institution to appeal to. That last one is the direct price of having no central authority, the same property listed as an advantage. Worth knowing that blockchain and cryptocurrency are not the same thing. Cryptocurrency is one application of blockchain. Blockchain is a general technique for keeping a tamper-evident shared record, and it is used for other things. Supply chain tracking, so that the origin of goods, food, medicines, minerals can be verified at each step. Medical records shared securely between institutions while remaining auditable. Voting systems, where an unalterable record is exactly what is wanted. Property and land registries, smart contracts which execute automatically when their conditions are met. The common thread is a situation where several parties need to share a record, none of them fully trust the others, and no single authority is accepted by all, which is precisely the problem the design solves. 4 things to take into the exam. First, define digital currency as currency existing only in electronic form, and cryptocurrency as digital currency that uses blockchain and has no central bank or authority. Second, define blockchain as a decentralized digital ledger of transactions held across many computers, in which each block contains the hash of the previous block. That last clause is what makes it a chain rather than a list, and it is often a mark on its own. Third, when explaining security, give the mechanism rather than the claim. Altering one block changes its hash, which breaks the link stored in the next block, so every subsequent block would have to be recomputed. And fourth, if asked to evaluate, give both sides and connect them. No central authority means no one can freeze your funds, and also means no one can recover them if you lose your key. The same property, seen twice.